dirty data is a central problem, and it comes from merging different data sources or input errors. And one of the challenges that we have here is that there are a bit two communities that work here. One is the statistic communities that works with numbers and arrays. The other one is the data engineering community that works with strings and databases. And so we need to sit in the middle of those two. So this is illustrated by the fact that in most machine learning papers, the data is assumed to live in a vector space. It's a matrix. However, in real life, the data is typically a dirty table that might have missing values or non-curated, non-normalized entries. So what can we do about this? Missing values, traditionally what you do is that you replace missing values by plausible values. This is known as imputation, and sklearn can do it. However, what we've shown in a recent paper is that imputation can be a bad idea because the target that you're trying to predict may depend on missingness. So you need to add a missing indicator, or for powerful learners, a simple imputation, like constant imputation, actually works better. But the best option is to use the support of missing values that comes in our latest Hist gradient boosting classifier. Now, when you have dirty categories, one of the tricks that we can use is that we can use their string representations, and we can encode them with their string representations. So instead of the traditional view, which is to do data cleaning using feature engineering, what we'll do is that we will represent the data using string similarities. And this can be done using the dirty cat library. The problem with this is that it might not scale very well because we might have an explosion of different strings. And so what we can do is that we can do a substring model that actually finds recurrent substrings and encodes on these recurrent substrings. So what we've learned working with dirty data is that we should do more learning and less cleaning. And for this, we need representations and models that can ingest non-curated data.